slurry is transported in the pipelines only when the slurry is having a critical speed. Without critical speed, the hydraulic mixture, that means the mixture of mineral and water, cannot be transported. Generally, the critical speed varies from 1.5 meters per second to 5 meters per second. This clearly depends on the density and size of the particles which is to be transported. And in this speed range, the small and light particles, that means the mineral particles which are to be transported through pipelines, if those minerals are light particles, that means which are having very low density, for example, compared to other ores, coal is of very low density compared to iron ore or compared to other metal ores. Coal is of very low density, so we can assume that it is a light particle. These kind of light particles can be transported through pipelines, and these particles will be suspending on the water inside the pipeline. Suspending on the water, what does it mean? Means suspending is nothing but these coal particles will be floating on the water while its way to transportation inside the pipes. And medium particles means is lighter, more denser than coal particles, like coal. Other mineral particles which are slightly of more density than coal, these particles will be, half particle will be floating on the water and half particle will be submerged in the water, and the flow rate will be common as we have discussed in the previous slide. And next, large or heaviest particles, that means the mineral pieces or the ore pieces or the material which is very heavy in density or which is large in size, will obviously completely get submerged in the water inside the pipeline, and they will definitely touch the lower portion or the lower wall of the pipeline, and it will be dragged throughout the length of the pipeline up to the discharge end. And in pressurized transportation system, a highly concentrated hydraulic mixture of extremely fine particles of clay, chalk, peat, coal and the like can be transported even at very low speeds. Here what I mean to say is, sometimes when we do hydraulic mining to transport a very soft material like chalk or clay, we know that they can completely get dissolved into the water. That means their particle size are very negligible, very small size. So this clay or chalk or peat or coal at high pressure incidents onto their faces, they can totally get crushed. After crushing, they will be mixed up with the water in a thick form of slurry, in a viscous form, and this slurry will be transported through the pipelines at a same speed without increasing or decreasing their pressure. Such hydraulic mixtures have certain suspension characteristics when they are at rest. That means even if any breakdown occurs during the hydraulic transportation, even if we stop the entire hydraulic transportation network in this pressurized transportation system, the particle or the mineral will not get settled in the pipelines and will not jam the pipes because they are already dissolved in the water. And in hydraulic transportation system, it makes possible to transport loads, that means nothing but large and huge quantity of mineral or the slurry can be transported through longer distances. For example, in USA, coal has been transported over a distance of 173 kilometers continuously without any interruption through this pressurized transportation system in hydraulic mining. And in the same country, ore is also successfully transported to a distances of more than 115 kilometers through this pressurized transportation system in hydraulic mining. And in order to successfully carry out this pressurized transportation system in hydraulic mining, we need to initially do some calculations appropriately for the exact design of hydraulic transportation systems. In that calculations, we need to consider some parameters like diameter of the pipeline, concentration of the solids in the hydraulic mixture, and the hydraulic resistances. Hydraulic resistances and the hydro-abrasive wear of pipeline are lowered drastically. That means the lower portion of the pipe will be eroded completely or slightly, because if the transporting mineral piece size is more, then obviously the lower portion of the pipeline will be eroded. That means the thickness will be decreased by continuous usage of this transportation system. So generally, in order to achieve successful transportation by this pressurized transportation system, we need to break up the mineral size from 1 to 3 mm. Thus, the hydraulic transport over longer distances is usually limited to particles of this size. So, if you want to transport the slurry or the hydraulic mixture for the long distances, then definitely the mineral size should be 1 to 3 mm only. So, in this hydraulic transportation system, we are having some advantages. Let us see what are those advantages. First of all, obviously, it achieves high capacity transportation. That means without any breakdowns, we can transport high capacity of mineral from feeding end to discharge end, and feasibility of transport over long distances. So here we are having more feasibility, because here the main component is water. We are having enough plenty of water, and we can recycle the water, so it is more feasible than other transportation media by using railways or roadways. There we will invest more costs in electricity or fuel charges and maintenance. Here low operational cost. Here operational costs are also very low, and feasibility of combining the transport of material with some other technological process. By using this, we have already seen some images in the slides, where from underground the coal is being pumped to the surface, and from surface, after screening, the coal will be dumped into a lorry, and from there the lorry will be used for transporting the coal to the required industries which are demanding the coal. So this is nothing but the combination of hydraulic transport and other technologies. And next, coming to disadvantages of hydraulic transportation system. In disadvantages, we will obviously discuss regarding a considerable consumption of water. That means we need plenty of water. That is one of the disadvantages, and we also need more electric power in order to run the high pressurized bore pumps or suction pumps, and wear of pipeline and pumps when transporting abrasive materials. That means when we transport heavy density materials through this hydraulic transportation system, obviously the pipelines may get damaged, and pumps may also get overstressed and may subjected to failure. So we need to change them. For that, we need to bear some additional costs, and in some cases pulverization and maceration of the materials being transported. Pulverization is nothing but in order of transporting those minerals from one end to other end. That means for larger distance, within that time the mineral may get diluted. The mineral may break up into again small pieces which cannot be used by the industry. So there may be a loss. That is nothing but the dilution of the mineral, which requires a subsequent dehydration also. That means after transporting the mineral or the slurry to the other end, that means to the discharge end of the industry, there the mineral should be taken off from the pipelines, and from there the mineral should get dried. That means it should be heated in order to remove all the water molecules from the mineral. That means it's nothing but subsequent dehydration before sending that particular raw material to the industry. And this is all regarding hydraulic mining. Thank you, class, and please go through these slides very carefully, and you can write the notes from these slides, and you can also maintain a running notes whatever I speak in this video. And in part 1 and part 2, you can prepare your assignments of at least 2 questions from each part from now. Thank you, students. if you are having any doubts regarding this topic in the part 2, you can directly mail me your questionnaire to surya3047 @gmail.com. Thank you, my dear students.